It's Miss Phoebus, and I'm back with another lesson, lesson 38, the introduction to completing the square. Now this week we're going to slow it down just a little bit. We've been doing two lessons, and cramming stuff in. That's so that we can take in some really brand new stuff. We need time to wrap our brain around. Okay, so we are going to be introduced to completing the square, and then we are going to then use that to do something else with it. So today's lesson is not the end. Today's lesson is just the beginning. Okay, so we are going to complete the square. Now, one of the vocabulary words that you have is an area model, and that is something that you've probably been introduced to in elementary or middle school. It's a rectangular diagram or a model used for multiplication and division problems in which factors or the quotient and divisor define the length and the width of the rectangle. You can use the method of completing the square to transform any quadratic equation to the form x minus p squared equals q that has the same solution. So our goal is to be able to transform something to where I can use the taking square roots method. Remember taking the square root of both sides and then getting x by itself. So, but this is like a precursor to that. That is what we're going to do tomorrow and work through. So here are our standards, and there's several about completing the square. So again, remember this is introduction to, so we're going to look at the process, but we're not going to actually solve anything today. So here's another one, solve quadratics by completing the square. Again, this is like we're getting ready to do that, but not quite there yet. Another one, use the process of factoring and completing the square to show zeros. Extreme values would be the ones that we're interested in. We should be able to see vertices. Again, that's going to be later, but we're definitely going to have to know how to complete the square. Not my favorite method for solving a quadratic, not like my go-to method. My go-to method is coming up soon. You're going to love it. But it is a method, and it is in our standards repeatedly, so we need to make sure that we understand what completing the square is. So we're going to turn to page 170 in your notes, and when you get there, you have 4 pictures, and I want to know which one doesn't belong. What do you guys think? Which one doesn't belong? This one right here, this one does not belong. That is the odd one out. Okay, and the reason why is, do you see how this square is in the top left corner? This square is in the top left corner. This square is in the top left corner. Those are the biggest pieces. What's in the top left corner here? Is that the biggest piece? No. Okay. Also notice these long rectangle ones are to the right of that big square. Ooh, this one we have 2 big squares. That's interesting. That one is different. Then we also have these long pieces underneath. And then we have these tiny little baby squares kind of on the bottom right. That one that I circled, the big circle, that one doesn't do much of that. Okay, so what we're doing, these are our area models, and we're going to look at these a little bit closer. But let's use one of these as an example. Now, when we're in class and it's not COVID season and we can touch things and share things, I pull out the algebra tiles. And the algebra tiles, this big square represents x squared. The little long pieces, or the skinny long pieces, these are each x's. And then each of these little tiny white squares are ones. So this would be x squared. There's 1, 2, 3, 4, 5 x's plus 6. And what I can do with this area model is I can say, well, this piece has a length of x, this piece has a length of 1, and this piece has a length of 1. So that looks like x plus 1 plus 1, that's x plus 2. And this length is x, and this has a length of 1 plus 1 plus 1. That's a 3, right? 1 and 1 and 1. So that's x plus 3. And you can use that style to help you factor. Now, that's kind of where we're going, but not quite, because this is called completing the square. The one that we were working with here, that's not a square. Squares have equal sides, right? This is x plus 2, x plus 3. Those aren't the same sides. This would be an x plus 1, x plus 5. That's not a square. This is x plus 2. This is 2x plus 3, not a square. So what we're going to have to do is we're going to have to build squares with this. Okay? Now, if you have highlighters or color pencils, probably not markers or Sharpies because it'll bleed through, but if you have something like that, color sometimes helps with this. So if you're one of those people, I'm one of those people with color, colors might be helpful. So what we're going to do is we're going to sketch the algebra tiles. We're going to sketch the area model. But what we want to try to do is we want to try to build a square because this is completing the square, right? So the x squared piece that I have here, I'm going to color in. So I have an x squared. That takes care of this piece. I have 6 x's. But remember, I'm trying to build a square. So I want to divide those x's up in such a way so that my sides that I'm building, the figure that I'm building, my sides are equal. So what I'm going to do is I'm going to divide this into where there's 1 and 1 at the bottom. So that would be x plus 1 on each side. And then, so that's 2 on each. And here's 3 on each. And so if I count each individual red rectangle, there's 6 rectangles shaded in. So that would be plus 6x. All right, and then I have plus 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And the nice thing is, guess what? It's a square. Now, in our lesson, we're going to have to complete the square. So there's going to be something missing, and we're going to have to figure out what that is to build the square. But let's look at the dimensions. So we already know that along the sides, we have x here and here. The width of this piece is a 1, this 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 is a 1. So we're going to come back to that in just a minute, okay? All right, let's look at number 2. Let's say we were going to factor this. So we would have 2 numbers that multiply to give us 9, add to give us 6. Okay, so what are 2 numbers that multiply to give you 9, add to give you 6? 3 and 3. So that would mean I have x plus 3 and x plus 3. And what do you notice about my parentheses? They're the same. So I can write this as x plus 3 squared, right? And so when we talk about squaring things and we are talking about having a square, those are kind of the same thing, right? Squaring something means that length times the width is the same thing. I can write it as something squared. So couldn't we say that this is x plus 3? Couldn't we also say that this is x plus 3? So what do you notice about the factoring and the picture? They agree, don't they? And we have this idea of a square. All right, so we're going to build off of that. So here, we only have a partial square represented. We are missing something, and what you're going to be missing on these is the constant. So we need to figure out for number 5 how many tiles to complete the square. So we're going to start building this. So we've got an x squared, so let's go ahead and shade that in. Now remember, our goal is to build a square here. Okay, so I have 2 x's, so I'm going to be able to fill in 2 rectangles. I don't want to fill in these 2 rectangles because that's not going to be a square. This side is going to be longer than this side. That's not going to work. Okay, so I want to split up my x's. I want to divide them into 2 equal pieces so that I put in this area, I put some x's, and in this area, I'm putting x's, and those are the same thing. So what I'm going to do is I'm going to be dividing this by 2. And so that means that there's one piece that goes here and one piece that goes here, right? 2x divided by 2 is x, 1x. Now the question is, right there, what goes in there? What would complete the square? Here would be my square. What do I need to add to this? Right here, I need to add 1 in there. So how many tiles to complete the square? 1. What are the dimensions? So after I put this 1 in here, and I was going to factor, this would be an x, this would be a 1, this would be an x, this would be a 1, so it would be x plus 1 and x plus 1. So my length is x plus 1, my width is x plus 1, and so that would mean I would have x plus 1 squared, right? So that would mean that I can write x squared plus 2x plus 1 as x plus 1 squared. And we've been looking at the factoring thing. What multiplies to give you 1, adds to give you 2? 1 and 1, and they're the same, so you can write the parenthesis twice. Okay, so our goal is to complete the square. So why don't you play around with 8, 9, 10, 11. Pause the video, see what you can do. All right, with the negative 6x, it's a little bit different. We're still going to treat it like we have been with the positive piece, but we do want to be careful. With the algebra tiles, there is one side that is one color, and then if you flip it over, it is red. So it looks like a negative, or the red means negative, I should say. So what we're going to have to do is when we put these x's in, we're going to have to remember that they're negative. So there's my x squared. What am I going to do with my x's? Remember, I'm trying to build a square. I want to divide them into 2 groups. So I'm going to have 1, 2, 3. I'm going to make sure I write negative 1 up here. Negative 1, negative 2, negative 3. There's x's. All right, so let's build a square. What are we missing? What do we need to complete the square? We need these guys to be filled in, right? All of these. Now, you might be like, well, is it going to be negative? Is it going to be positive? So a negative 1 times a negative 1 is a positive 1. So you're going to have that all the way through. So all of this 9 should be positive, plus 9. So how many tiles to complete the square? 9. Where are the dimensions? X minus 3, x minus 3, that I can write as x minus 3 squared. So you just got to be careful. This sign is important here. So I can rewrite x squared minus 6x plus 9 as x minus 3 squared. All right, so we're going to look at this algebraically, get away from the picture and do it more algebraic. So here is x squared plus bx plus c. The goal is to be able to write it as x. Now this plus or minus is going to depend on what's going on here. If that's a plus, then we're going to have a plus inside our parentheses with the x and the p. With the minus, we'll have a minus. This plus or minus doesn't mean we include both. You will have to choose one based off of what the original problem is. But you should be able to write it as x plus something squared or x minus something squared equals, and this is a cube, not a 9. It's a cube. All right, so what we're going to do is we're going to take the b value, divide it by 2. Then we're going to square this number, and that is going to be considered it'll be this c value. That c value is what we're talking about. And then when you go to plug it in and you rewrite it, then inside the parentheses, it's going to turn into p. Now, we will be doing something with that. The number itself will change a little bit. So we're going to fill in the missing c, and then we're going to rewrite the trinomial as a perfect square binomial. So you need to do both parts in the homework. So I need you to label c equals and give me that number. And then I need you to go ahead and rewrite it as some sort of parentheses squared. What's going on in the parentheses is depending on what's going on in the problem. So here's what we're going to do. We're going to take b, we're going to divide it by 2, we're going to square it. And this is like a little formula to help you with your completing the square piece. So what is our b value? Our b value is negative 10. We're going to divide that by 2, and then we're going to square it. So we're going to do the stuff in the parentheses first. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So what we have is we're really dealing with x squared minus 10x plus 25. And we want to factor that into our perfect square trinomial. So we're going to have a parentheses squared. Remember that whole square root thing? This is where it's helpful. The square root of x squared is x. The square root of 25 is 5. And then because we have a minus in front of our 10x, this is going to be minus x minus 5 squared. Now, one key, especially if you're not wanting to do that, you want to see something else that's different. Before you square this piece, this negative 5 and this negative 5 are the same negative 5. So before you actually square and get c equals 25, which I told you to label and write down, and then I didn't do it. So c equals 25, but before you square it, that's the piece that goes inside. And that's going to help us in some of these later problems figure out what should go inside the parentheses. So let's look at number 13. We're going to do b divided by 2, and we're going to square it. So what's our b value? The b value is negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So c equals 4. There, I labeled it this time. All right, so that means, and we can even mark this out here, we can put a 4 there. Now, you can do the square root piece. You can do it as x. And then, ooh, look, do you see here, before I squared it? Minus 2 squared. It's a different way to do it. So we didn't do the square root piece. We just took what was that number before it was squared. I've got one more way to look at it, and it doesn't matter which one that you use, okay? Just you need to get a way to look at factoring this into that perfect square. All right, b divided by 2 squared. Our b value is 12. 12 divided by 2 is 6. 6 squared is 36. So that is your c, 36. All right, so then now let's look at just factoring. What are two numbers that multiply to give you 36, add to give you 12, and they should be the same number, 6 and 6, so that we get x plus 6 squared. There's three ways. So any way that you do that, whether it's you do this, the shortcut, the square root piece, where it's you borrow that number before it's squared, or if you just factor it. You have multiple ways of doing it. It's just you've got to get one that works for you and can get stuck in your head. All right, now, you will never be asked to complete the square in Algebra 1 if there is a number, a leading coefficient that is not 1. Your leading coefficient will always be 1. Now in Algebra 2, different story. And you will have extra work to do. So I will never ask you to solve something with completing the square when a is not 1. Now, when you are like, here's a quadratic, solve it any way that you want to, and it's like 2x squared plus 5x plus 13, and you choose to do completing the square, I wouldn't. Don't do it, because I haven't taught you what to do with that 2 in the front. Remember, I taught you what to do with it when in the factoring, the slide and divide, but I didn't teach you what to do with it here. So you're probably going to only want to do completing the square when I tell you to. And a lot of times it'll be something like this where it's like, especially on the end of course, where it's like, what can we add to this so that we can complete the square? And they will kind of push you towards completing the square. Like I said, completing the square is not my number one method. It's actually the last method that I would be doing to solve a quadratic. I would graph and I would factor before I did completing the square. But it is something that we are required to teach, so that's why I'm teaching it. All right, let's look at the last three. They have odd b values, so that means we're going to be creating fractions. So that means we're going to take b, we're going to divide it by 2, and we're going to square it. That means b is -3 divided by 2 squared. Now this is where, using the piece that I did here where I was like, hey, take that and just plug it in, remember? This is one where that's probably the best way to do it. We still need to figure out c, so we're just going to square each part. -3 squared is 9, 2 squared is 4. So that is my c value. But I probably don't want to do the other pieces where I'm trying to factor. I just want to do x minus, because that's a minus, 3/2 squared. Now, a lot of you will want to pull this piece up and put it in front of x. I caution you because we have a 1 in front. If you do that, then that creates, if you go back and multiply, create something where there's not a 1 in front, there's another number in front. There would be like a 4x squared. So don't do that. All right, so let's look at this one. B divided by 2 squared. So our b value is 7. 7 divided by 2 squared. Just going to square each piece. 49/4. That is our c value. But we've got to write it as a trinomial squared, or perfect squared trinomial. So this is going to be x. This is a positive 7/2. So I'm just going to write 7/2. You can multiply to check it. But b divided by 2 squared. So we're going to have -5 divided by 2 squared, which is 25/4. I don't know why I drew parentheses, but they're there. So that's our value, c equals 25/4. And so we're going to have x, and this is a -5/2. So we're going to write -5/2 squared. All right, that's it for today. We're learning how to complete the square, why it's called completing the square, because we actually built a square out of things, and then we turned it into a squared binomial. So play around with these, see what you can do. I'll see you in the next video. Bye.